Okay, everybody, welcome back. This is Mr. Purdy, and this is going to be a video on nothing but exponents. This is all about exponents, and you can see what I did here. I just got all of this from Google Images. You can see exponents everywhere, so you might as well just look at this at some point, because a lot of what we're going to be talking about here is just pictures I got. Okay, exponents. We'll first start off, I know many of you were here when we did this, but with the SOLs, and sometimes we came to class, we were a little tired, that kind of thing. So you might want to go over this one more time. So here it is. First of all, zero exponents. And we want to realize that any number raised to the power of 0, any number raised to the power of 0 is 1. So a quick little proof. What we're going to do is take 3 to the power of 4 and get 81. 3 to the power of 4. 3 times 3 times 3 times 3 is 81. 3 to the power of 3, 3 times 3 times 3 is 27. 3 squared is 9. And what we're doing is we're dividing each one of these by 3. As we decrease my exponent here, we're dividing by 3. So 9 divided by 3 is 3. So 3 to the first power is 3. Now here's 3. So here's a little proof. If I keep dividing by 3, then what I'm going to get is 3 to the power of 0 is actually 3 divided by 3, which is 1. What we're doing is we divide by 3, is we're getting 1 at the very end. So 3 to the power of 0 is 1. Just a quick little proof, not a really big time proof, but just a visual proof for you to help you there. Okay, a couple quick examples. X to the power of 0 doesn't matter what it is. Anything raised to the power of 0 is 1. 3 to the power of 0, 1. 1,324 power of 0, 1. X, y squared power of 0 is 1. 7 to the power of 0 is 1. Negative 7, we take the entire quantity, negative 7 raised to the power of 0 is 1. However, if I don't have parentheses, I have a negative 7 to the power of 0. Without parentheses, it's actually going to be 1 with a negative sign in front. So negative 1 is the answer. And to try that, put that in your graphing calculator, and you'll see. If you put 0 to the power of 0, you're going to get an error message, which is undefined. You can't raise 0 to the power of 0. Impossible to do. So basically, your walkaway is anything raised to the power of 0 is 1. Anything at all. Power of 0. Okay, how about negative exponents? Your textbook will tell you that a to the power of negative n is not negative. It's 1 over a to the positive n. As long as, of course, a can't be 0. Okay, you can't take 0 to a negative exponent. Not going to happen. Okay, on the other paper we did all this. We divided by 3. If I continue, here's where we stopped last time, but if I continue to divide by 3, I'm going to get 3 to the negative 1 is actually 1/3. Not negative 3, 1/3. Now really this is just a pattern. 3 to the negative 2 becomes 1 over 9. 3 to the negative 3 is 1 over 27. 3 to the negative 4 is 1 over 81. And 3 to the negative 5 is 1 over 243. Okay, these do not become negative. They just become flipped over. Think of it like this. If I have 3 to the power of negative 2, think of the whole thing over 1. Think of it as a fraction over 1. Anything that has a negative exponent is bad and needs to be moved down below. So I'm going to take this whole entire thing, because it's bad, and move it downstairs. When I move it down, it becomes positive 2. If there's nothing, once you move it, it becomes a 1. So what you have now is 1 over 9, and that's how we got that, 1 over 9. We'll practice more of these, but that's the general idea. Okay, again, if it's not a fraction, put it over 1. So it's going to become 1 over 81. 9 squared. Not a fraction, put it over 1. 1 over 5 cubed, which becomes 1 over 125. Okay, not a fraction. Now, the 4 is good. We're going to leave the 4 alone. 4 stays upstairs, but the x negative 2 goes downstairs, just like so. Now, the difference between example 3 and example 4, the whole thing is bad here. So put the whole thing over 1. Now we're going to move the entire 4x downstairs. 4x, keep it parentheses, 4x. But now it's going to become a positive 2. And that's going to become 1 over 16, 4 squared, x squared. And there's your answer. Okay, I'm going to erase. And we'll continue. And the nice thing about a video, like I said last time, is you can pause it and rewind it to your heart's content. Okay, not a fraction. Put it over 1. Anything that's good stays where it is. So 5 is good. 5 didn't do anything wrong. A cubed is good. The b negative 2 needs to come downstairs to become positive. Okay, this side real quick. It's not a fraction, put it over 1. So you're going to have 2. 2 is good. X negative 3 comes down. And y negative 4 comes down. That's it. Sometimes you're going to have a bad person downstairs. That's okay. Just move them up. So what you have is your fraction bar. The 1's okay. The 5's okay. The x negative 3 is bad. It needs to be moved upstairs to become good. You don't need that 1 there, but you can put it there. No big deal. Okay, 7 and 8, very similar, but you can see number 8 has the parentheses. So this time the entire thing is bad. So we're going to move up the entire 5x, move it upstairs, and that's going to become positive 3. And it's over 1. You really don't, if it's over 1, you don't need to put that. So it's going to become 5 cubed, which is $1.25, and then x cubed. Good enough for me. Okay, let's do example 10 real quick, and I need a little bit more room to do example 9. Example 10, this whole bottom is bad, so just move it up. It becomes x to the 5th over 1. Or better yet, just x to the 5th. Okay, example 9. Real quick, example 9. 9 is really not that much more hard. It just takes a little bit more room. So let's do it. Example 9. Everything is to the power of negative 3. So we can actually, here's our fraction bar, and we're going to write it as 3 to the negative 3, x to the negative 6. This is what we call power to a power. I'm getting a little ahead of myself in this problem. I don't know why the textbook gave it in this early in the unit, but that's all right. We're gonna learn all these properties to get these later on. Okay, I'll just put it over 1 for now. So what's bad? Whatever's bad needs to come downstairs. So here's another fraction bar. I'm going to take this guy right here. He's bad, negative exponent, and move him down. 3 to the positive 3. This is easier than you think it is. It really is. X negative 6 comes down. So x positive 6. The y15 stays up top. He didn't do anything. And there it is. You can write 3 cubed as 27. So you can either write it like that, or you can write it as 27. I actually prefer 27. And there it is. Okay, that's 0 and negative exponents. Okay, now, more properties. Product of powers property. And don't get too caught up in the titles here. I just need to know how to do the idea. The bases must be the same, just like that video all about that base. The bases must be the same, and when the bases are the same and we multiply, we add the exponent. So it comes n plus n. A lot of times when I give you textbook formulas, it doesn't make a whole lot of sense. That's why I like to give you numerical examples. So this really becomes 5 cubed times 5 to the 6. This is not 25. Just keep it 5. And now we add the exponents. 3 plus 6 is 9. This property right here, we'll put a little star, is probably the most important property. It can be used time and time again. Okay, bases are the same. First thing you want to check for, bases are the same. Add the exponents. So 2 plus 4 plus 7 would be x to the power of 13. Same base, negative 7, negative 7, negative 7. Keep it negative 7. And then add the exponents. That's a 1. 5 plus 1 is 6, plus 11 is 17. Okay, sometimes you're going to have a number in front. In that case, just multiply. There's no properties for that. It's just 4 times 9, 36. Don't use properties of exponents for that. A lot of kids will put 13. They'll add 4 plus 9. It's not. 4 times 9 is 36. Now we use the exponent properties for exponents. Z's are the same. 5 plus negative 12 is negative 7. Okay, now the negative 7 is bad. We can never have negative exponents. So as we learned in the previous slide, we're going to move it downstairs. And then we're going to have 36 over z to the positive 7. It's always easier than you think. It really is. Okay, take your numbers, multiply them. 2 times 9 times 3 is 54. And then we want to go alphabetical order. Two different variables here. Go alphabetical order. A1 and then A2 is A3, A cubed. And then we have B to the 4th. Yeah, when you get to the variable, always put your number first and then alphabetical order. Okay, I think we covered this when we did scientific notation, but it wouldn't hurt to review one more time. What you do is you take your eyebrow. 3 times 5 is 15. Times 10. Always times 10 when you do scientific notation. Add the exponents. 5 plus negative 12 is negative 7. Now, remember, this is not scientific notation. We're going to make this smaller. So 1.5. We made that smaller. If we do that, we're going to make this one bigger by adding 1. Remember, that becomes negative 6. And there's your answer. Okay, moving on. Power to a power. This one's kind of quick. A to the m raised to the n power is a to the m times n. And again, sometimes that doesn't make as much sense. So let's just practice one. 3 to the 5th squared. Now think of it as 3 to the 5th. Anytime you square it, you write it twice. 3 to the 5th times 3 to the 5th. And remember what we do. We add exponents. 5 plus 5 is 10. We can also go 5 times 2 and get the same answer. It's just a little quicker way to do it. That's all. This becomes y to the... Now I could write y squared 6 times and add them up and get 12. But why do I do that? 2 times 6 is 12. A plus 1. Keep the expression in parentheses. A plus 1 squared to the 5th power. Again, I could write it out 10 times, but why would I? 2 times 5 is 10. Okay, n to the 4th to the 7th power is n to the 28th. Okay, y cubed, we'll leave that alone. That's going to become y to the negative 10. So y cubed, it's going to be y cubed times y to the negative 10, which becomes y to the negative 7th, which becomes 1 over y to the positive 7th. Okay, we're going to do this part first for the r's. That's r10. Negative 5 times negative 2 is 10. r10 times, always times r cubed, which becomes r to the 13th. Power to a power. Power of a power too. Sometimes you'll hear a phrase like that. Either one. Okay, power of a product property. This one's just as important as everything else. It's not really, I don't know. It's kind of like the distributive property. So if you have an a, b in parentheses and all raised to the power of x is ax times bx. So basically, it's kind of like the distributive property, but it's really not. Everything inside the parentheses gets the 4. So it's going to be 3 to the 4th, 3 to the 4th times x to the 4th. 3 to the 4th power is 81, so you can write 81 x4. Usually the idea is if it's kind of a small number, I want the number. If it's a big number, like if it's like 7 to the power of 12, that's a huge number. You don't just leave it like that. But if it's like, 5 squared, 3 to the 4th, it's relatively small. Usually if it's less than 100, write out the number. Okay, so 4 cubed. I'm going to write it all out so you can see it. Times y cubed. Everything gets cubed. Everything in the parentheses gets cubed. Z cubed, which becomes 64 y cubed z cubed. Okay, big difference here. You have a negative number in parentheses, so it's going to be negative 2. Keep the parentheses. Negative 2 squared times w squared, which is going to become 4, positive 4, w squared. Now I want you to look at the difference between this one and this one. This one, the negative sign is on the outside, so we're going to square everything first. We're going to take 2 squared, not the negative sign, 2 squared, w squared. And what we're going to get is 4w squared. But don't forget that negative sign. We need to add it at the end because it's not included in the squaring. Okay, this is going to become, and these problems just take a little bit longer. They're not really too much more difficult. N to the power of 10. So n10. That's that, n10. Okay, 4 times 4 cubed. M cubed. N negative 6. Okay, more work to do. Number first. 4 cubed is 64. Alphabetical order. M comes before n. So m cubed. Now you have 10 plus negative 6, which is 4, positive 4. And there's your answer. Okay, I'm going to do this problem right down here. So I'm going to go 6 cubed, a cubed. I'll tell you, everything comes down to these properties. And remember, they're on my sideboard. Okay, 5 squared in my classroom. They're on the sideboard. And then a negative 6. Okay, let's do the numbers first. That's 216. 6 times 6 times 6 times 25. I have my calculator right next to me. 216 times 25 is 5,400. So 5,400. Okay, that's the numbers first. Numbers. Remember, there's no properties for numbers. Just cube that, square that, multiply them. Now, 3 plus -6 is a -3. And by the way, if you try to skip steps here, you're going to most often make a mistake. Okay, we're smart people, but man, you've got to take your time when you do this. Okay, 5,400 b cubed is all good, but down below the a -3 needs to come downstairs. Remember, when you don't have a fraction, you have negative exponents. Put the whole thing over 1, and there you go. Okay. Sometimes you're going to be asked to use a combination of properties, okay? So let's just continue on. So 4 cubed, x, see this is power to a power, x6 y cubed times x to the 5th. If there's no number, put a 1. So you have 4 cubed is 64. We're going to get really good at 4 cubed, aren't we? 64. Okay, alphabetical order. 6 plus 5 is 11. Add the exponents. You've got to know when to use which property. And then y to the power of 3. There's only one y, so just y 3. Okay, 2 to the 5th. X to the 15th. Y to the 5th. All times x to the 5th. Okay, 2 to the 5th is 32. 2 times 2 times 2 times 2 times 2. 32. Now add the exponents. 15 plus 5 is 20. If you remember every property and use it the right way, you'll get these right all the time. If you take your time, write it out, and use the properties, you're going to get it right. Okay, -3 is in parentheses. -3 squared is 9. Okay, I'm just going to write 9. We know that -3 times -3 is 9. A to the 12th. 6 times 2, right? Power to a power. 6 times 2. B to the 4th. All times 1. That's an invisible 1. A b cubed. You get good at these. It's actually kind of fun. 9 times 1 is 9. I know, you're laughing at me. It really is. 12 plus 1 is 13. A 13 and B 7. And there it is. Okay, moving on. It's kind of weird, like I said last time. It's so weird. I'm used to pausing and asking for questions, all that, but it's a video, so I'm going to keep going. Bring any questions to class. Heart to the 14th. These are real quick. Just want to make sure you understand it. 3 to the 23. That's a case where that would be a really, really big number. So leave it like that. I don't need to know what 3 to the power of 23 is. Okay, that's going to be 27. 3 cubed. B cubed times B, which becomes 27 B4. It all comes down to the 6 properties I have on my board in my classroom. Okay, A to the 14th. Okay, whenever you have a negative number in parentheses, leave the parentheses. Okay, don't lose the parentheses. -2 to the power of 17. -4, keep it. -4 to the power of 2 times 3 is 6. Okay, x 15, y 40. Okay, a cubed, b cubed, c 6. All of that times a 4 b squared. Now, add the exponents. So you have a7, 4 plus 3, right? 3 plus 4, 4 plus 3. b5 and c6. Okay, this one looks tricky, but it's really not that bad. Okay, 3 -4, j -16, k, jk. Yep, they're laughing at me. Okay, times k -8, and then j, 8 times 4 is 32. Okay, we'll worry about 3 -4 in a second. Let's just combine 3 -4. We'll just write that. Let's do our j's. Add the exponents. -16 plus 32 is +16. For the k's, negative 24, negative 8 is negative 32. Now, create a fraction. I'm going to move this down. Becomes 3 to the positive 4. Don't need that. J16 stays. I'm going to move the k negative 32 down to become k to the 32. You could write 3 to the 4 as 81. So I'll accept 3 to the 4 or 81. Either one's fine. So there's your answer. J16 over 81k32. Yikes. Okay. Final property, quotient of powers property, is just basically division property of exponents. It's a, given the bases must be the same. The bases always have to be the same. So a to the m minus n. Start on the top. Always start on the top. M minus n. Remember, you can't have, the key here is you can't have any negative exponents. So it's going to become 5 to the 6. Always on top. Start on top. 6 minus 2, which becomes 5 to the power of 4. M to the 2 minus 7, which becomes m to the negative 5. No negative exponents, which becomes 1 over m to the positive 5. Okay, m. Just do the m's right now. 2 minus 5. And then n, they're multiplied. 4 minus 3. Now, if you get a positive exponent, you're done. But a negative exponent, you got to keep going. So m, 2 minus 5 is negative 3. 4 minus 3 is 1. So the n's are done. Now, it's negative. It needs to go downstairs. So we're going to put the m cubed downstairs to become positive. And there's your answer. See, that negative went down. Okay, 3 to the 3 minus 4. Be very careful here. 3 minus 4 becomes 3 to the power of 7. And again, if it's a positive exponent, you're done. Okay, negative 5. Negative 5. Keep the parentheses. To the 9 minus 9. Well, 9 minus 9 is 0. It's in parentheses, so positive 1. Okay, x to the 4 minus 4. Please, please write all this out. Don't take shortcuts. Y to the negative 1 minus 5. Z to the 8 minus 1. Okay. 4 minus 4 is 0. X to the power of 0 is 1. That whole thing is gone. It's just a 1. It's gone. Okay, negative 1 minus 5 is negative 1 plus 5. Becomes y to the power of 4th. And then z to the power of 7. So really, out of all of that, we're going to get y, I'll put it down here, y to the power of 4, and then z to the power of 7. Power of a quotient. Okay, this is where everything gets multiplied by the parentheses. What we're going to have is a to the x over b to the x. Everything gets multiplied. Very similar to the property we did a while back here, only there's a fraction this time. So it's going to become 1 to the 5th over 2 to the 5th. Okay, which is 1 times 1 times 1 times 1 times 1, which is 1, over 2 times 2 times 2, which is 32. Remember, these bases are not the same. We cannot subtract exponents. Okay, 5, negative 3. Everything gets multiplied by negative 3. Everything gets the exponent 4, negative 3. Now, both of these are bad. If you have a situation where both are bad, just flip it over. So you're going to get 4 to the positive 3 over 5 to the positive 3. Remember, these bases are not the same. Leave it. Okay, so you can get 64 over 125. 4 times 4 times 4, 5 times 5 times 5. Okay, 3 cubed over 5 cubed. Bases are not the same. Leave them alone. So you can get 27, 3 cubed, over 125. Okay, power to a power. You can get x to the 18, 3 times 6, over y to the 30th. No reducing. Don't reduce. Don't do anything here. We're done. We're done with that. Okay, Last slide here, and then we're done. Last slide is just a combination of all of this stuff. If you can do these five, really understand the last part of this. Okay, this has got like everything here. All right, what we want to do is r 3 times 4 is 12. So r to the 12th over r to the 24th, which becomes r. Bases are the same, so we can go 12 minus 24, which is r negative 12, which becomes 1 over r to the positive 12. That's it. Okay, when you get a whole mess in here, there's two ways to do it. You can actually simplify everything inside the parentheses first and then cube it, or you can write it all out. I think it's easier to write it all out. It's more writing, but I think it's easier. Now, these are in parentheses. You have negative 6. It's a negative number, so let's keep it in parentheses. To the 3 cubed. X to the 6. Remember, everything gets cubed. Y cubed. Okay, there's your top. On the bottom, 2 cubed. I should just put 8. X cubed. And then y to the 9th. Okay, that's going to become negative 6 times negative 6 times negative 6 is negative 216. X to the, okay, let's get rid of these, 6 minus 3. Y to the 3 minus 9. And don't forget down below we had an 8. Now, we can divide this number into this number. Don't use properties, just divide, straight up divide. So what you have is negative 216 divided by 8, which is 27. Now the larger number is on top, so it's going to make the whole thing negative. 27. The 8's gone, because 8 goes into 216 27 times. Now, x to the third power, x cubed. Now this is y to the negative 6, 3 minus 9, which needs to come downstairs. And there's your answer, positive 6. Remember, the whole thing's negative, though, because we had a negative number here. There's your answer. You can have a negative number. You can have a negative fraction. You can't have negative exponents. Please know that. You can have a negative answer. You cannot have negative exponents. Okay, bear with me. 3 more, everybody. 3 more, 3 more, 3 more. And then we're done. I'm recording this on your student holidays, so I'm actually ready, going to be ready to get out of here myself. Okay, here we go. Third one. Okay, give yourself a little fraction bar. So 2, it's not negative, so we don't need parentheses. 2 negative 3, x negative 18. These problems, some of these look really tricky on the surface. If you just try it and write it out, you'll be fine. Y negative 12. Okay, everything is bad. Everything is bad, so everything needs to be switched. So 2 cubed, 2 negative 3 comes down here. X negative 18 comes down here. And the y negative 12 that was downstairs comes upstairs to positive 12. And you can write that as a big 8. And there you have it. Can't do anything here. Different bases. We're done. We're done. We're done. Don't reduce anything. We're done. We're done. We're done. We're done. We're done. We're done. Okay, 2 more. Oh, erase. Helps if I hit the erase button, not the pen button. And I'm using green because tomorrow is St. Patrick's Day. Okay, what I usually do when I get something like this is I just straight up multiply. I know some of you can cancel. That's really confusing. Let's just multiply it all out. Top times top, bottom times bottom, and then we'll simplify. So 4 times 5 is 20. Remember, no properties for numbers. X cubed times x is x4. This problem has almost everything in it. Y cubed times y squared is y to the 5th. Okay, down below, 2 times 2 is 4. X, there's only one x, and then 2 y's, y squared. Okay, divide your numbers just like you've done for years. No properties here. I have kids put 16 because they subtract these all. Don't. It's just 5. 20 divided by 4 is 5. Okay, now we use properties. x4 over x1 is x to the 4 minus 1, and then y to the 5 minus 2. So there's nothing on the bottom, so we don't need the fraction anymore. So 5 x cubed over y cubed. Oh, that worked out. Okay, I believe I've actually given this problem to you all before, but it wouldn't hurt to do it one more time. We're going to take a scientific notation divided by scientific notation. What we're going to do is take these two numbers first. If you have a calculator at home, you take 3.6 divided by 9, and you're going to get 0.4 times 10. Always times 10 with scientific notation. Okay, you're dividing, so subtract the exponents. Negative 10 minus 6, which becomes plus 6, which is negative 4. So you're going to have 0.4 times 10 to the negative 4. The problem is that's not scientific notation. We're going to make this one bigger, move it over 1. If we're going to do that, we need to make this one smaller. So times 10 to the negative 5. Okay, now, a couple things. If you were in my honors, first period, fourth period, seventh period, we didn't really cover this at this time of the year. We covered these notes way back in September, so hopefully you kind of picked all this up. And if you haven't taken your quiz yet on exponents, you will. Regular students, please watch this video because you have never seen this before, some of you, because we will have a quiz on exponents coming up in the near future. Okay, just check on your calendar for that and check the board. Okay, that's your exponents. So watch this to your heart's content, and I hope you will do fine with this. I'm sure you will. I'm sure all of us will do great.